Pascal's triangle, and we're going to see how this is used for the binomial expansion. So you can see this first row starts with 1, then we have 2 1s here, and then each subsequent term is determined by adding the 2 numbers above it in the previous row. So here 1 plus 1 is 2, okay, and then if we look, and we keep the 1s running down the outside. So here 2 plus 1 gives us 3, 2 plus 1 gives us 3, here 3 plus 3 is 6, 1 plus 3 is 4, 3 plus 1 is 4, and so on. And we're going to see how this is useful for binomial expansions. So if we have something of the form x plus y to the power of n, where n's a positive integer, and we want to look at some cases. So if we look at x plus y to the power of 0, well, this is equal to 1. If we look at x plus y to the power of 1, this is equal to x plus y. If we look at x plus y squared, this is equal to x squared plus 2xy plus y squared, and so on. You can see this first one, we get 1 as our coefficient. Here we get 2 1s as our coefficient. Here we get 1 2 1 as our coefficient, and this pattern happens to continue. So the question is, well, how do we determine the powers of x? And the way we find each power is we look at the power of our total expression, and whatever n is, we make that our first power of x, and then we go along and we subtract 1 from the power of x and we add 1 to the power of y. Bear in mind the power of y starts at 0. So here x starts at n, which is 0, y always starts at 0, so that's what we get. Anyway, this one, x starts at 1, y starts at 0, so we just get x, and then y moves up to 1 but x goes down to 0, we get this. Here you can see we get the familiar pattern. So to write this formally, x plus y to the n is equal to the sum from k is equal to 0 of n, choose k, that's what this notation is, and we'll look at this in more detail in future videos, of x to the n minus k, okay, because when k is 0, that's our x to the n, so we're starting with n, and y to the power of k. Okay, so all you need to know about this term here is this gives coefficient, and this gives this table here. So the trick is, if you say you got x to the 5, you go to this 5th row here, you just start reducing your powers of x, increasing your powers of y with these coefficients. So let's do that expansion. So x plus y to the 5 would be 1 times x to the 5 times y to the 0, y to the 0 is just 1, and then plus 4 x to the 4 y to the 1 plus 6 x cubed y squared plus 4 x squared y to the 3 plus 4x y to the 4 plus y to the 5. Okay, so hopefully this makes sense. Note this, just as I say, n choose k, so it's out of n objects, it's a number of ways we can choose k of them. So when k is equal to 0, we've got whatever our power of n is, how many ways can we choose 0? When k is equal to 1, how many ways can we choose one object, and so on. But as I say, we'll look at that more generally in the next couple of videos. Hopefully this video was helpful. If it was, please like and subscribe, and if you've got any questions, let me know in the comments, and I hope to see you in the next one.